Hello students, I hope all of you have seen my first video on congruency, and in this video I am going to explain some sums related to those rules. Now suppose we are having one question like this. In triangle ABC, here ABC is the triangle, angle A equals to 100 degree, AB equals to AC, we are to find angle B and C. We know when two sides of one triangle, if this one and this one they are equal, then their opposite angles must be equal. Angles opposite to the equal sides are always equal. So these two sides equal, that means angle B must be equal to angle C. So here I have written AB equals to AC. It is given in the question. So AB is opposite angle, that is AB's opposite angle, that is angle C, must be equal to AC's opposite angle, that is angle B. Let it be equation number 1. Now in triangle ABC, in this triangle ABC, we know angle A plus angle B plus angle C must be 180 degree. This is called angle sum property. A already we know it is 100 degree, it is given in the question. B, I have written B, and since B and C are equal, so I can write instead of C angle B, and this is equals to 180 degrees. Now angle B plus angle B, twice angle B equals to 180 minus this 100. If you transfer in the other side, it will become minus 100. That means twice of angle B equals to 180 minus 180, angle B will be equals to 40 degree. And since we know angle B equal to angle C, that means both the angles will be equals to 40 degree. Question number 2. Suppose in this figure it is given AB equals to AC. AB equal to AC means this side equals to this side. It is given in the question, and angle ACD equal to 105 degrees. What we are to find? We are to find angle BAC. Now let me explain this sum. Here we know this one is 105 degree and this angle is not known. We know since this is a straight line, BCD is a straight line, so angle ACD and angle ACB, sum of these two angles, this angle plus this angle, together it will be 180 degree. So angle ACB plus 105 equal to 180. Now this angle I don't know, so angle ACB plus 105 equals to 180. So ACB equals to 180 minus 105, that means angle ACB becomes 75. Clear? In the next part, it is given that AB equal to AC. Since AB equals to AC, that means we know whenever two sides are equal, their opposite angles must be equal. So since these two sides equal, these two angles, angle B and angle this part C, these two must be equal. So since angle C is 75, angle B also must be 75. Now, already we have proved that angle ACB and angle ABC equal to 75. That means ACB and ABC, these two are 75 each. Now, in triangle ABC, if we use angle sum property, then sum of these three angles will be 180 degrees. This one is 75, this one is 75. So I can write angle BAC plus 75 plus 75 equals to 180. That means angle BAC plus 150. That means if I add 75 and 75, I will get 150 equals to 180. That means angle BAC comes out to be 180 minus 150, that is 30 degree. That means the required angle BAC equals to 30 degrees. The next question is, in triangle PQR, if PQ equals to QR, in triangle PQR, PQ equals to QR and LMN are the midpoint of sides PQ, QR and RP respectively, you are to prove LN equals to MN. Now in the solution we have to write like this. In triangle PQR, PQ equals to QR and LMN are midpoints of sides PQ, QR and RP respectively. This we have to prove LN equals to MN. In the construction part, we have to add LN and MN. So we have written LN and MN are joined. Now let me prove. In triangle PQR, PQ equals to QR. It is given in the question, and we know angles opposite to equal sides are equal. Since PQ equals to QR, so opposite of QR is angle P and opposite angle of PQ is angle R. These two angles must be equal. So angle P equals to angle R. Let it be equation number 1. Triangle LPN and MRN. In these two triangles, this PQ equals to QR we know, and L and M are the midpoints. Since PQ equals to QR and LM are midpoints of PQ and QR, so this side equal to this side, L is the midpoint, M is the midpoint, so PL, this part must be equals to MR, because PQ equals to QR, half of PQ must be half of QR. So I can write PL equals to MR. This part clear? Next part, angle P equals to angle R, already we have shown, and PN equals to NR because N is the midpoint. Since N is the midpoint, PN must be equals to NR. So here you can see side, angle, side. So triangle LPN must be congruent to MRN because side, angle, side, angle, side, triangles are congruent, and since triangles are congruent, their corresponding parts must be equal. So Ln equals to Mn by CPCT, that means corresponding parts of congruent triangle. Whenever triangles are congruent, their corresponding parts are equal. Now next question is, this figure is given to you and it is given that AB equals to CF. Next it is given EF equals to BD and angle AFE equals to angle CBD, that means this angle. Clear? These two sides are given, these two sides are equal given, and these two angles are equal given. What you are to prove? You are to prove triangle AFE congruent to CBD. Here AB equals to CF, AB equal to CF, it is given in the question. If I add FB with both the sides, here AB equal to CF, AB equals to CF, we are adding FB with both the sides. So AB plus FB equals to CF plus FB. Just see AB plus FB, CF plus FB. Now AB plus FB, it will be AF, CF plus FB, you are going to get BC. So AF equal to BC, let it be equation number 1. Now, if you consider these two triangles separately, suppose you are having AEF and DBC. So in these two triangles, AF equals to BC from equation 1, already we have shown. Angle AFE equals to angle CBD, this is given in the question, and this EF equals to BD, it is also given. To just see side, angle, side, angle, side. So if I write AFE, I must write CBD. That means the triangles are congruent by SAS, congruence property. And this is what we are to prove. So the next question is, in triangle RTS, it is given RT equals to TS, RT equal to TS given, that means this side equals to this side. Angle 1 is given as twice of angle 2, angle 4 is given as twice of angle 3, and we are to prove triangle RBT congruent to triangle SAT. Now in the proof section, just see here RT equals to TS. We know in a triangle, if two sides are equal, their opposite angles are equal. Suppose you are having a triangle like this. If this side equal to this side, that means this angle must be equals to this. So since here RT equals to TS, so this full angle, that is TRS, must be equals to TSR. This is equation number 1. Now 1 and angle 4. Angle 1 and angle 4 are equal because they are vertically opposite angles. From chapter 6, you know that vertically opposite angles are always equal. That means angle 1 will be equal to angle 4. And as you can see in the question, it is given that angle 1 is twice of angle 2 and angle 4 equal to twice of angle 3. So I can write instead of 1, twice of angle 2 equal to twice of angle 3. On cancelling 2 from both the sides, we will get angle 2 equals to angle 3. Now if we subtract angle 2 and angle 3 from these two, that means TRS minus angle 2 and TSR minus angle 3. So TRS minus 2 and TSR minus 3, I am going to get this angle equals to this angle. That means TRB equals to TSA. Fine. This is our equation number 3. I have drawn separately RBT and SAT. So in triangle RBT and triangle SAT, TRB equals to angle TSA. It is from equation number 3. RT equal to TS, it is given in the question. Angle T equals to angle T. This is common since it is present in both. So triangle RBT congruent to triangle SAT. This is what we are to prove. Here question is, in this figure, C is the midpoint of AB and angle DCA equal to angle ECB and DBC equals to angle EAC. These two angles equal, and C is the midpoint. What we are to prove? That DC equals to EC. So here in the question it is given angle DCA equal to ECB, DCA equal to ECB. These two angles equal. On adding DCE on both sides, so we are adding DCE, this angle with both the angles. So this plus this, these two angles if I add, I am going to get this angle ACE, and if I add these two angles, I am going to get BCD. Fine. So I am going to get ACE equal to BCD. Let it be equation number 1. Now if I take triangle ACE and BCD, here these two angles are equal. It is given in the question. This AC equal to CB because C is the midpoint, and angle ECA and DCB, these two angles are equal. Already we have proved. So angle side angle, triangles are congruent. Since the triangles are congruent, so their corresponding parts are equal. That means EC must be equal to DC. Hence proved. Let me explain the last sum of this chapter. This figure is given, and it is given AD is the bisector of this angle A, and we are to show that AB is longer than BD and AC is longer than CD. I hope the question is clear. Now how to solve it? We have named these angles as 1, 2, 3, 4, 5, 6. And since AD bisected this angle A, so angle 3 must be equal to angle 4, and let it be equation number 1. Now in triangle ADB, I can write angle 1 equals to 3 plus 5, exterior angle property. So 1 equal to 3 plus 5. That means 1 must be greater than 3 because angle 1 is the sum of these two angles. So 1 must be greater than angle 3. Say angle 1 is, suppose we consider angle 1 is 90, angle 3 is 60, and angle 5 is 30. So if I compare 90 and 60, which one is greater? 90 is greater. Similarly, angle 1 equals to 3 plus angle 5. So I can say angle 1 is greater than angle 3. Angle 1 is greater than angle 3. But we know angle 3 and angle 4 are equal. So instead of angle 3, I can write angle 4 because we know angle 3 equals to angle 4. So angle 1 and angle 4, if I compare, angle 1 is greater than angle 4. And we know the property side opposite to greater angle is larger. So out of 1 and 4, angle 1 is greater, so its opposite side, that is AC, is longer than 4's opposite side, that is CD. Now in triangle ADC, using exterior angle property, I can write angle 2 equals to 4 plus angle 6 because in any triangle, exterior angle equals to sum of interior opposite angles. So here, just like previous case, angle 2 equals to 4 plus 6. That means angle 2 must be greater than angle 4. So angle 2 is greater than 4. And since 4 and 3 are equal, so angle 2 is greater than angle 3. So angle 2's opposite side, that is AB, will be longer as compared to the opposite side of angle 3, that is BD. So we have proved AC is greater than CD and AB is greater than BD. This is what we have to prove. So that's all for today. Take care. Bye bye.